Hello students, pleasant greetings to you all. Welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and welcome back to another Csec tutorial session. In today's video, we're going to be talking about transformation geometry. In fact, I have a series of videos that are coming out that I will be walking you through every single details as it relates to this particular topic. So if you definitely want to not only use this video as a form of preparation for your soon upcoming exams, but in general you want to be able to understand in depth about transformation geometry, be sure to hit that subscribe button below, turn on your post notification bell, leave some positive questions and comments down into the comment section below, and do not forget to share this out to your mathematics community. Of course, do not forget to hit the like button. It really does help the channel to grow. So without further ado, let's jump right into the video. As well as be sure to check in the description box below. You will find more personal information and details as it relates to not only this video but videos that are mentioned in also this tutorial session. So for this particular video, we're going to be taking on one aspect of transformation geometry, and of course we're going to be talking about translation. So again, without further ado, let's jump right into today's session. So of course, here on screen we have a bunch of information here which I'm going to be walking you through, and I'm thinking that maybe we're going to be here for about 45 minutes to an hour. So I want to walk you through not only examples but graphical demonstrations to give you a more thorough understanding of transformation geometry. But in this particular session, we're going to be talking about translation. Now, transformation geometry, by definition, is the method by which an object is mapped onto its image, which means that the object is going to be changing its location. And there are various ways in which an object can change its location. Throughout this series of transformation videos, I'll be walking you through what is known as the translation, which is what we're going to be dealing with tonight, reflection in later tutorial, rotation, and enlargement. Translation pretty much moves the object from one location to another location. Reflection will flip the object. Rotation will turn the object, and enlargement will change the size of the object. Now, of course, the object can simply just be a single point, which means that you could be asked to map a point onto its image, or it could be 2 points that are connected, which basically forms a straight line. We could also be asked to reflect a line. It could also be a polygon consisting of 3 or more sides, such as a triangle or a quadrilateral or some odd looking shape. It doesn't have to be a specific shape that has a name. It just has to be a series of points connected together to form some sort of polygon. Now, that's pretty much the essence or the idea behind transformation. It's just basically using a mathematical and graphical approach to moving the object, which in this case could be a shape, a line, or a point, to a new location on the Cartesian coordinate system. Now, for this particular video, we're taking on the topic of translation. And so by definition, just to be more specific, translation is the movement of an object onto its image by means of a slide and a glide. So it's a combination of the two. Now, what usually happens is that the object is going to then slide along the x-axis, and of course after sliding along the x-axis, it's going to then glide along the y-axis. Before we get in depth in that information here, it says that this is a result of a 2-by-1 metric that is usually written in the form x, y. Now, assuming that you may have a little bit of knowledge on the topic of matrices, that will make this explanation way easier, because we're going to be doing addition of matrices, or we're going to be perhaps later on doing multiplication of matrices using row and column. Now, of course, if you've never done matrices, or you also have problem with matrices, then you're going to find then that even though this video requires prerequisite knowledge of matrices, it is still going to be easy for you to understand. So, of course, as I said, the slide and glide is as a result of a 2-by-1 matrix that is usually written in the form xy, and this is known as your translation vector. Now, from the vector, the x represents the total amount of units along the x-axis that the object is going to slide. So moving, or the translation vector, is pretty much acting as if you're actually plotting a point, or you're replotting a point. So if the object, let's say for example, is a triangle, and the triangle has 3 points, then each piece of that triangle will move by the same vector. So each of the points will be moved by whatever the value of x represents here, left or right, and then the value of y will tell us whether we go up or down. The y, as I said here, tells us the gliding movement, the amount of units moved along the y-axis. So the object is basically going to be making some sort of L movement to its new location, or we could simply say each of the vertices on the diagram or on the shape will be moving in an L movement. So the object, the whole entire object, consisting of however many points, will either move to the left and then it goes up, or it can move to the left, then it goes down. It can then move to the right and go up, or it can move to the right followed by a movement going down. So you're going to have several combinations of 2-by-1 matrices, or several combinations of translation vector. So as discussed earlier, it could be, say here, the standard xy, or it could be, say, the standard here, negative x, y, or it's possible that it could be x, negative y, or finally, it's going to be negative x, negative y. And there's only 4 possible combinations. Well, in fact, there are 6 possible combinations, because of course, sometimes the object does not necessarily have to move to the left or right. It can literally make 0 movements to the left or right. Then it can move actually a certain amount of units up or down. We would label that position 0y. Or in this case, then it could actually make a certain amount of units to the left or to the right without making a movement up or down. So that would be labeled, say here, x0. Now, for these 2 particular points, 0y and x0, they are going to be points that lie exactly on the standard x-axis and y-axis. But we're going to get more in depth when we get to that point. As we approach the graphical representation of this, I will show you how these things are applied. Now, for you to really get to the basic understanding of what a translation is, visually, as we said, the object is going to be making somewhat of an L movement. So the object is always going to be moving to the left or right, followed by a movement up or down. Now, we use a very standard formula here. And this formula here, as seen here on screen, is O plus T equal I. And so what does the O, the T, and the I stand for? That is the object point, or it could be object points, given that the shape has more than one points. Then each of the points that makes up the object will be added to the translation vector. And so by adding corresponding coordinates, then you're going to find the location of the image point. Now, to make more sense of it, let's get into the calculation aspect. We're going to start off this particular video with some worded problems without any graphical demonstration. Now, please note that, of course, if you have an equation with 3 unknown variables, to find any one of those variables, then you must be provided with 2 of the variables of the 3. So therefore, in the formula, O plus T equal I, if the question requires you to find the object point, then most likely you would have to be provided with the vector and the image location. Similarly, if it is that you want to calculate the vector that moved the object onto its image, then most likely you would have to be provided with the object point as well as its image. And of course, traditionally, if you wanted to find, say, the image point, most likely you'd have to be provided with the object point and the image point. Let's use these very basic worded examples to get a feel of not only the calculation but the L movement that we're referring to earlier. Now, it says here in this question, and I've used some color codes here for you, so just to make it easier. It says here that the point A has coordinates 2, 4, and undergoes a translation by the vector 5, 2. Our task is to calculate the coordinate location of the image A, and that little dash here means A prime. So most times, now and in the future, our object will always be indicated by A prime. A little dash is like it's like a complement. Okay, so without the complement, that is the object, and with the complement, it is the image. So when you read this question, you have to determine from the formula O plus T equal I what information was provided to you. And so it says, according that the point A has coordinates 2, 4. That means A is your object point. So we're going to just write this in a column form here, 2, 4. Okay, and then so of course we're going to be adding that to the fact that it undergoes a translation by the vector. So the vector that moved the object is 5, 2. And so they're basically asking us to calculate the image. So of course the image then would have been the sum of the object point and the translation vector. And as I said, prerequisite knowledge of matrices, where we add corresponding entries, then easily then this will work out to be 2 plus 5 is equal to 7, and 4 plus 2 equals 6. So after a translation of 5, 2 on the object point 2, 4, then the new position, which is the image, is going to be located at 7, 6. Of course, we're not going to be going on graph for this one. Let's scroll down here to this particular question where we alter the formula. Remember that this particular video here is a complete guide into the topic of translation. We are not going to leave 1 ounce of information out. We're going to be discussing every crevice, every corners of this particular topic. So at the end of this video, you most likely will have all the answers to all the questions that you currently have and questions that you may have in the future. The point B has coordinates -3, 5 and undergoes a translation by the vector. AB. So in this case, we weren't told what the vector is. But what we do know is that whatever translated -3, 5, pardon me, then we know that it was mapped onto the image, which we now know is -1, -7. Our task is to calculate the values of A and B. So in other words, we want to calculate the ordinate values that make up the coordinate of the translation vector. So once again, since the keyword in this question here is translation, we're going to have to resort to our formula here, O plus T equal I. Now, some instructors will perhaps tell you that, okay, if you know that you are looking for the vector, you can transpose the equation and make T the subject of the formula. So, of course, you could say then, okay, since I want T to be my subject, then I'm going to immediately just go right ahead here and transpose O to the left side. So you might find some instructors telling you that the translation vector formula is that T is equal to I minus O. Now, provided that you guys have been on my channel and you've been watching my most recent tutorials, of course, a link will be in the description if you want to master your skills in transposition and its application. What we're doing here is just simply applying base knowledge of transposition to transformation. Now, I'm particularly not going to be using what another instructor would have done. I'm going to simply here just use the normal formula and do my basic transposition. So then I'm looking here easily then that the object point based on the question is -3, 5. And so I'm going to be adding that to, obviously, I do not know what T is. So T is going to be represented by the vector, the 2x1 matrix, A, B. Know for certain that whatever translated -3, 5 is simply going to be mapped onto -1, -7. So now easily then, all I have to do now is to transpose or carry over the whole entire matrix -3, 5. So I'm going to go ahead then and I'm going to carry this matrix over. Now please note that whether it goes in front or behind, it doesn't matter as long as you naturally then make the subject, say here, negative. So we're going to have AB, which is the matrix we're looking for, AB, and we're going to therefore then go ahead and write this matrix here, -1, -7, and when we carry this matrix over, we're just pretty much carrying the whole entire bracket, or carrying the vector. We're not changing the signs of what is inside. So many students resort to the fact that, okay, if I transpose the O, then the entries on the inside should change. In fact, we're moving the plus sign here to the other side, so this becomes minus, and we keep whatever values are still inside the parenthesis. So this is still -3, 5. Okay, so therefore then easily we can have a final answer here of -1 minus -3. So since minus and minus becomes a plus, then -1 plus 3 is 2. So we can say here that A, B is equal to, at the top, we just calculated this to be 2. And of course at the bottom, -7 minus 5, that is minus 12. So by comparing matrices, because both matrices have now been simplified to 2 by 1, we can compare corresponding entries. Therefore, then we can safely say that A is equal to 2, and then by comparison, B is equal to minus 12. And that is simply how you get the answer to a worded translation question without any graphical representation. Let us then apply the same concept then to, of course, the question down here. So now we're looking at, say here, the point T undergoes a translation by the vector minus 4, 5. And it was mapped onto T prime 3, negative 7. We are to calculate the coordinates of T. So as we said earlier, that without the complement, that letter is going to represent the object. With the complement, it's representing the image. And again, the key word in this question here is the fact that it went through a translation. So we know right away that we're going to be running towards the formula O plus T equals I. Again, if you feel comfortable in saying T is equal to I minus O, be my guest. No problem. Both formulas are correct. I particularly just kind of like to stick with the traditional way of just simply writing down my matrix O, which in this case is the letter T. And then of course the vector, pardon me, I have a plus sign here. It's supposed, sorry, I have an equal sign, it's supposed to be a plus. I know that the vector based on the question here is of course the vector minus 4, 5. So that's minus 4, 5 here. And then of course, I know it was mapped onto T prime. So I know that over here, T prime here, which is the image, is going to be, say here, 3, negative 7. Now, once again, it's the same procedure. I'm going to go ahead then, and I'm going to carry this matrix to this side. Bear in mind that we're not changing the signs of the entries inside. We're literally transposing this plus matrix here to the other side. So therefore then we end up easily with the fact that T is then equal to 3, negative 7, and we're going to be subtracting, say here, negative 4, 5. So then we can easily go ahead and say T is therefore then equal to 3, take away negative 4, these two negatives becomes a plus because they multiply each other. So 3 plus 4 is 7. And then of course, negative 7 take away 5 is negative 12. So therefore, the translation vector that literally moves T, which was unknown, pardon me, the object T that was moved by the vector minus 4, 5 and became 3, negative 7 was in fact 7, negative 12. All right. And that pretty much gives us our first real understanding of what translation really is. And this is from a worded aspect. So have some fun with some worded questions. Of course, I will try to provide links to useful sites where you can get useful translation questions and you can exercise this very simple skill that we just learned, how to move around the formula of O plus T equal I. All right, so for this particular segment of the video, we just went through the worded calculation for translation vector. So we're then going to move across then to the graphical approach to this question then. And so with the graphical approach here, we want to go on the graph and see how the question is applied. Now, for this question here, we're looking at, given that the triangle ABC has coordinate values A, minus 1, 5, B, 3, negative 2, and C, 4, 2, all 3 points basically will form a shape. Of course, it's going to be forming a triangle. Now, this triangle undergoes a translation by the vector -3, -5. Our task is to 1. Calculate the coordinate values of the image A prime, B prime, C prime, and of course we're going to be drawing the image on the graph. Now there's two ways to do this. You can use the calculation, and after the calculation we just plot the results of the calculation on the graph, or we can actually plot the point on the graph and just follow the direction that the vector basically gives us. So what I'm going to be doing here is that I'm going to be doing the graphical application of this first of all. So let's start off here. Our points. I'm going to be going here with yellow. So the first thing here that I want to do is plot the point A, which is -1, 5. So I'm of course going to go here and I'm going to take 1 step to my right and of course 5 steps up. So that is 1. Then we go 1, 2, 3, 4, 5. I'm going to be right. Next, I'm going to go ahead and plot 3, -2. So that's going to be 3 to my right. So that's going to be 1, 2, 3. Then I'm going to go down 2, 1, 2. Going to be right here. All right. And we're going to be calling this point, say here, A, and this point, say here, B. And then finally then, we're going to go ahead and plot the point 4, 2. So of course, we're going to go across, say here, 4. So that's going to be 1, 2, 3, 4, and up to 1, 2. So this is our point, say here, C. I'm going to proceed then to connect C to B. I'm going to then connect A to C, and I'm going to finish off by connecting, say here, A to, say here, B. And so I have this particular triangle that I am looking at here. Now, from a graphical perspective, what the question is actually saying is that each vertices on this particular triangle will be moved by the vector. So that means each of those points are going to take 3 steps to the left, then it's going to take 5 steps down. So this simply means then that from point A, for me to locate A prime, I'm going to take from A, I'm going to take 1, 2, 3 steps to my left. Then I'm going to take 1, 2, 3, 4, 5 right here. That's going to be my A prime. Now for C, same procedure. I'm going to go ahead then and I'm going to take 3 steps to my left. So from C, which is my starting point, I'm going to take 1, 2, 3. Then I'm going to take 5 steps down. 1, 2, 3, 4, 5. That's my B prime. Then I'm going to take here from B, pardon me, that's going to be my C prime. Sorry guys. From B, I'm going to go ahead and take 3 steps to my left. Say here 1, 2, 3. Then of course I'm going to take 5 steps down. So from here 1, 2, 3. 1, 2, 3, 4, 5. See here, that is my B prime. Now I'm going to go ahead then, I'm going to connect, say here, each of these. I'm going to say here use say blue, and I'm going to connect, say here, A here with C. I think that's not straight enough, guys. It's a much better line. It's a little lean, guys. I'm not using a ruler, but you guys should be using a ruler. Connect C here to B, and then of course finally here I'm going to connect A prime here to B prime. So it's there's a little belly, but if you have your ruler, guys, I'm using my computer screen, so it's a little lean, but you guys are going to have your ruler and you can be drawing your image with broken lines. Now you can choose to draw it with broken lines and label it A prime, B prime, C prime, or you can just draw it with bold lines and still label it A prime, B prime, C prime. Okay, so therefore that is your translation, and this is without calculation. This is perfectly acceptable. However, for the student who perhaps want to do a little calculation, then we could go ahead then and write down our formulas here. Say here O plus T equal I. And so in this case here, our object points will not only be just 1 point, it will be 3 points simultaneously. So here, let us go back and put our original object point, which of course we started off with the fact that this is -1, 5. So that's -1, 5. And then we're going to go to, say here, B and plot 1, 2, 3, 3, -2. I think we were given the points up here already. So that's 3, -2. And then of course then the last point, which is 4, 2. Both of these, all three of these points are going to be moved by the vector, of course, say here, -3, -5. And so of course, by adding corresponding entries of each column in our object matrix, then if we add -1 to -3, we're going to end up with, say here, -4. If we add 3 to -3, we're going to get 0. And if we add 4, say here, to say here 1. Then of course here we're going to say here 5 plus -5, we're going to get 0. Then of course -3 plus -5 is -7. Pardon me. So -2 plus -5 is -7. And lastly, 2 plus -5 is -3. So therefore then, this would be our calculation for A prime, B prime, C prime. Now, in this case now, we're going to actually go on the graph and we're going to plot these points in column 4. And the exact location of A prime from the center of the origin here, from the origin point here, we're going to take 4 steps to our, say here, left, and then 0 means that we're not going to go down or up. So from here, let's zoom up from the center of the origin here. We're going to take 1, 2, 3, 4. Already you can see that we are on A prime, and 0 means that we do not go up nor do we go down. So we stay on the axis. Next then, 0 minus 7 means that we're going to take 0 units or 0 steps to our left or right. Remember, the top numbers will tell us whether we go left or right. So this means 0 on the x. So we're going to still be at the origin, and then negative. Not go left or right, we simply go 7 steps down. 1, 2, 3, 4, 5, 6, 7. And then of course we're at B. So for C then, we're going to go ahead then and take 1 step, because it's positive, we're going to go into the right direction, and then 3 steps down. So from the origin, we're going to take 1 step to our right. It's going to be 1 step in this direction, then 3 steps down. 1, 2, 3. And that lands us on C prime. So at that point, we would have obviously had all 3 points labeled, and we would go ahead and connect all 3 points, which will form the same shape. Let me know in the comments what method you prefer. Do you prefer doing the calculation and be sure of the actual points, or do you want to just use the graphical approach by just moving the points according to what the vector? Csec do not necessarily Csec, which is the course that I normally teach, that's for Caribbean students, but this video is particularly made for everybody who is doing the topic of transformation. There are certain ways how they ask the questions, so you have to be very familiar with how your examination body tends to ask the questions and get used to that method. Okay, and there you have it. That is the translation. It then begs that maybe we just need to try this one more time with a fresh question here. And so I have another question at the bottom here, which I'm going to be trying. So therefore, then I'm going to go ahead and I'm going to erase these points then. Just give me a second here, guys. Let me just get rid of these points. Beautiful. Let's go ahead then, and we're going to be plotting some fresh points. Let's use, say here, green. All right. So given that the triangle ABC has coordinates values A, -2, -1, B, -3, 3, and C, 3, 1, undergoes yet again a translation by the vector -1, 5. We are to calculate the coordinates. Let me just, if I can zoom up this question here. It did say, let's see here, guys. I'm not able to see the question. It says, calculate the coordinate values of the image A prime, B prime, C prime, and draw the image on the graph. So it's a very similar question. This is just for repetition purposes. So let's go ahead and plot the point -2, 1. So -2 is 1, 2, and this time we're going to go down 1. So that's right here. We're going to go ahead and plot -3, 3. So that's -3. That's 1, 2, 3. And up 3, 1, 2, 3. That's this direction right here. And then, of course, last one here is 3, 1. So from the origin, 1, 2, 3, and 1 here. Say here. Okay. We're going to then go ahead and label our point. That is A. Of course, we're going to label our point here, say B. I believe this is actually A. My apologies, guys. So this was the first point that I plotted. And then this becomes my, say here, B. And then this obviously becomes my C. All right. So I'm going to go ahead then and I'm going to connect here. I'm going to connect here. And then I'm going to connect here. Okay, so I have this triangular shape. And so, of course, each of the vertices, each of the points of the vertices of this particular shape will be moved -1, 5. That means each point on the object is going to take 1 step to the left and 5 steps up. So again, let's say here, let's use, say here, a yellow, I guess, or let's use a white this time. Okay, so then from A will take 1 step left, so 1 step here and 5 steps up. That's 1, 2, 3, 4, 5. It's going to be right here. Okay, so let's just move this letter that we named with B here. So this is going to be point B, and then of course here we said that this moves -1, 1, 2, 3, 4, 5. So this is going to be right here. Next, then, of course, we're going to be moving from B, then -1, 5. So that's -1, and then 1, 2, 3, 4, 5. This direction here. So this is, see here, A, and then this is going to be, say, that's A prime. This is going to be B prime. Okay, and then of course C will take 1 step to the left and 1, 2, 3, 4, 5 right here. That's my C prime. And so of course we can connect this with broken lines if we so desire. Okay, connect here, and then we're going to go down here, and that's my shape. All right, so the white one is a translation of the green shape. And of course you can verify in your calculation that the points are correct. So of course we're going to go ahead then and just erase this previous calculation here, and then we're going to go ahead then and do our calculation. So of course the original points were in fact -1, say here 5. Was that the point? No, I'm so sorry, that was the previous question. Let's go down here. So this was actually -2, -1. So that's -2, -1, Then we're going to go again and grab the points. So that's minus 3, 3, and 3, 1. Minus 3, 3. And we said here 3, 1. All of that there becomes my object points. I'm going to be adding that to the vector that says take 1 step to the left and 5 steps up. And so by calculation then we can go ahead and add corresponding entries. So minus 2 at the top plus negative 1 equals minus 3. And then of course minus 3 plus negative 1, that's minus 4. And 3 plus negative 1 is 2 at the bottom. Minus 1 plus 5 is 4. 3 plus 5 is 8. 1 plus 5 is 6. And so this becomes my A prime, B prime, C prime. Let's verify that the points match exactly the white diagram that we have here. So of course you'll see then that minus 3, 4 means that I'm going to, from the origin, take 3 steps to my left and 4 steps up. So that's 1, 2, 3, 1, 2, 3, 4. Bam, lands right onto, say here, A, our previous point. B prime is minus 4, 8. So we're going to take again 4 steps to my left. So that's 1, 2, 3, 4. Then 8 steps up. 1, 2, 3, 4, 5, 6, 7 onto B here. Beautiful. And then of course 2, 6. We're going to take 2 steps to my right. So that's going to be from the origin here, from the center point here. 1, 2, then up 6. 1, 2, 3, 4, 5. Aha. Right onto my object point here, C prime. So you as a student have to decide what method you prefer. Do you prefer the calculation? Well, I would recommend knowing both because one is quicker and more efficient, and the other one, I guess, depends on the question. Maybe the question requires you to show the calculation. So it's best you get used to both methods. All right? And that's pretty much how we approach translation. Now, one of the challenge that you're going to find many students have is identifying a translation when the object and the image is already drawn for you. So what happens if, say for example, you go on an exam paper or you're doing a practice question, and so on screen, as you're seeing here, we have a green triangle that was pre-plotted for you. It doesn't have a specific location because right here, there is no indication of where the origin is. So we're not very concerned about the coordinates of A or the coordinates of B or the coordinates of C, nor are we concerned about the coordinates of A prime, the coordinates of B prime, and the coordinates of C prime. What we're most concerned about is recognizing whether a translation takes place compared to that of a reflection, a rotation, an enlargement, or a combined transformation. So in order for you to safely know that a translation took place or it occurred is by understanding some basic properties of translation. Now, the following properties are key to recognizing when a translation has occurred, given that the object and the image are already drawn on paper, like what you're seeing here on screen. So one of the things that I particularly use, right, is the fact that, number one, when I look at the object, the shape, and I then compare it to how the image look, they should look absolutely equal in all respect. In other words, they should be congruent. So therefore, I should use my visualization skills and say that ABC looks very, very similar, or they're exactly the same in terms of length, in terms of angles, and in terms of area, just by observation. Because once you're on the Cartesian coordinate system, then everything is drawn to a scale. Now, number 2 is like my go-to property. The moment that I looked at an exam paper and they're asking me, say for example, what transformation took place, once I have all the knowledge of the rotation and the reflection and the enlargement, my go-to property is that I easily recognize a translation once my object and my image are identical in appearance. Meaning that the image, in this case, which is the blue triangle, is at a different location, but it is identical to how my object look. And the moment I see that, I know that a translation took place, because no other transformation has an identical appearance between the object and the image. They have similarities, they have a bit of congruency to them, but this is the only transformation where congruency and similarity remains constant or is consistent. And of course, unlike the other transformations, well, maybe enlargement, magnification, positive, there's always some sort of switch in the orientation of the points. So you're going to find that in a rotation, when A is on the left and it rotates 90 degrees or 180 degrees or 270 degrees, A will most likely probably be, say here at the start on the left, but after it rotates, it goes to the bottom, or it goes to the right, or it goes at the top. Same thing for B. B was at the top, it's then going to go to the left or to the bottom or to the right, and C that is on the right may go to the top, then go to the left, then go to the bottom. So there's always a change in the orientation. But if you look here at the translation that A was on, A prime is also on that side. The side or the part of the diagram that B is on, B is at the top. Then in the image here, B remains at the top. And of course, C here is on the right. Then it also remains on the right for the image. So there's a lot of little things that you can use then, right? Many of my students in the past and also in the present somewhat struggles to identify and compare the transformations once they have learned it. So hopefully those key little properties there help you out in the near future. And so here we are to, let's say that this was the question that was given to you. You're then asked to determine fully the transformation that maps ABC, which is the green triangle, onto A prime, B prime, C prime. Now, the description of this particular transformation requires you to not just name the type of transformation, but for example here, say for translation, you must therefore then state the vector that moved the object onto its image. If it was, say, for a reflection, you'd have to state the line of reflection or the mirror line, which we're going to be discussing in part 2 reflection video. And of course, if it's rotation, you have to not only state the angle of rotation, but you must also state the direction of rotation and the center of rotation, the coordinates of the center of rotation. For enlargement, very similar to that of rotation, you're going to have to state not only that the fact that it's an enlargement, but you must state the scale factor as positive or negative. In fact, if you name the scale factor, then it automatically tells you if it's a magnification or a reduction. And you must state, most importantly, the center of enlargement. So for this then, we must then state, obviously, that A, B, C, here we have to write it as a sentence. So we're going to say here that triangle ABC was mapped onto triangle A prime, B prime, C prime describes a translation by the vector, and here's the bit that you must know: how to state the vector. Now, in order for you to state the vector, remember that when a translation occurs, the vector that moves C to C prime must also be the same vector that moves B to B prime, and that must also be the same vector that moves A to A prime. So I'm just going to check the vector that moved C to C prime, and then just make certain, just to be sure, that there isn't any combined transformation involved, because it can sometimes look a little bit tricky if you're not paying attention to the coordinates. So sometimes it may be rotated and it somewhat has the same sort of look, but the orientation might change. So you have to be careful when you have tanked up yourself with all the knowledge of transformation. So here, just to check C, it seems as if to get to C prime, I may have to take 2 steps to my right. So already I know that my 3 steps up. So from C to C prime means I'm going to take, say here, 2 steps to my right and 3 steps up. So I'm going to just use that as my answer here. And just to verify that 2, 3 was the correct answer, I'm therefore going to take 2 steps to my, say here, right, 1, 2, and then 3 steps up. That should take me exactly to B, 1, 2, 3. Correct. So we know it's consistent between C to C prime and B to B prime. And of course, most definitely it will be consistent for A to A prime. But let's just double check here. From A, we're going to take 2 steps to our right. That's 1, 2. And of course, we're going to take 3 steps up. 1, 2, 3. So fully confirmed that ABC was mapped onto A prime, B prime, C prime by a translation vector 2, 3. All right. So there you have it, guys. That is translation, the easiest of all the transformations when it comes to description, when it comes to plotting point, when it comes to moving the object along the Cartesian coordinate system. Of course, later on, we're going to be talking more about combined transformations with translation. We're going to be talking about glide reflection that involves translation, so on and so forth. So there's going to be a bunch of stuff coming, guys. I'm going to have some very detailed video on each level of transformation. Next up on the channel, we're going to be talking about the reflection transformation. Very in-depth topic that I am having a lot of graphical demonstrations. So of course, if this is your first time here and you definitely have learned something from this tutorial, please be sure to hit the subscribe button below. Turn on your post notification bell for future tutorials. Leave your questions and comments down below. Check the description box for any useful advice, tips, links, and how to get into my live online classes. And do not forget to hit the like button before you leave. It really does help the channel to grow. So I want to thank you so much, guys, for staying with me for a little bit under an hour. And I do hope that, of course, you got some value from this content. Let's transfer our knowledge into the next upcoming topic, which is reflection. So until then, take care, keep on practicing, guys, and you're going to be geniuses in soon and very soon. Take care. Until then, bye-bye.